for listeners that we have out there who have been listening to this episode and been thinking, wow, I too would like to make a big impact on the world with quantum computing. How can our listeners start? How can somebody become competent, become a professional in, I guess, quantum computing in general, but then also quantum ML more specifically?
Yeah. So if you have a background already in machine learning, then perfectly equipped already to do quantum computing. I think one of the misconceptions is that you have to be a quantum physicist or a physicist in general to do quantum computing. You only have to be one of those if you want to build a quantum chip. If you don't, if you want to use it, so these concepts of superposition and entanglement, while initially it may be hard to wrap your mind around it, you don't have to be a physicist. The problem really is a different one. The problem is that usually when we get in touch with these concepts, we're grown ups. When I studied, so I read books early on when I was young about physics, but really how I got in touch with quantum physics was at university. So now you're 18, 19 years old, and then you learn about quantum physics, and all of a sudden, it seems everything you know about this macroscopic world is not true. So it is still true in some sense, but the fundamentals, the underlying physics is completely different. And that is sometimes confusing. So I think if we would start to think about these concepts at an early age, maybe through quantum games, whatever it is, that would be very helpful. But now back to your question. So I think if you have some engineering background or some technical background already, work in data science already, then the leap to quantum computing is not that hard. It's a technology like GPUs. So people today, they don't worry about using GPUs anymore in deep learning. It's just something that you can easily add to the stack. That's what we also try to do with the software that we develop, make it easily accessible. But of course, there is more work to do. But in the end, it can be understood, it can be learned, and it doesn't take a degree in physics. That's what I want to convey here.
Now, so is there somewhere our listeners can go to learn about the Terra approach specifically? I mean, it sounds like a great solution to allow people who already have a machine learning background, like you said, to be able to be tackling quantum ML problems. Is there somewhere on the Terra website that people can go to where people can get started, maybe, some open source code or some examples that allow people to get going with the Terra approach?
Absolutely, yeah. We have our TQ42 platform. If you look that up, you'll find it online. We have our code documentation that will help you to get going with first examples. We have publications on the website that exactly describe how everything works down to the equations, if that is something that someone is interested in. And then we offer TQ Academy. So TQ Academy is our own training program. So please reach out, and if you're interested, we train at universities, we train companies, anyone who is interested in quantum computing, and that involves, of course, not only the Terra Quantum products, but the fundamentals about what is it, what is quantum computing, when does it make sense to use, what will happen in the future, where will it benefit AI, and how, for example.
Very cool. I found the TQ Academy and I will include a
Mhm.
link to that in the show
Yeah,
notes.
perfect.
Thank you, Florian. And then for people who likewise, say they learn about Terra Quantum or some other quantum ML library out there, what kinds of problems in machine learning would you recommend as fertile ground where there's a lot of opportunity for people to be, pointing their interest, making a big impact, or being able to get a lot of business?
So, in terms of which problems to look at, you mean?
Yeah, exactly. Like, there's, we know that quantum computing is especially well suited to solving some kinds of problems like the traveling
Yes,
salesman problem or
yes.
encryption. And
So,
so, yeah, in terms of machine learning, what are other kinds of application areas where there's a lot of fertile ground?
so all regression, all classification, that is fertile ground. So, if you do image classification, if you do deep learning, even or large language models, then quantum computing can be interesting. Large language models, by the way, this is a very active area of research. So, how can you hybridize those? We're doing a lot of work here. We're not the only ones, but this is something where still a couple of open questions need to be answered. But generally, if you have any machine learning problem, whatever it is, there is a chance to efficiently hybridize it. In production, I would think about cameras for automated inspection. So you have a vehicle production and you want to inspect if there is some damage in the chassis when it comes out of the production line. So these are things to think about. Any classification of medical images, really anything. In self-driving vehicles too, a lot of image classification. So that's an important thing. You may be able to train a hybrid algorithm using a quantum computer, but for the inference, you don't need it. You can run the algorithm, it's been trained, the optimal configuration has been found, but then it may not be needed to have a quantum computer for inference. So you can deploy it in a mobile device, even if it was trained hybridized.